The last and least common method to find a resultant vector is to use sine and cosine rule. Do bear in mind, however, that this method is limited because it's only applicable if you have three vectors involved. In other words, you can only use this for vector triangles. If you do not have a triangle, then you cannot use this method. Now, let's review what was sine and cosine rule. If you have a triangle with sides A, B, C, and corresponding angles of A, B, C here, cosine rule tells you that A square is equals to B square plus C square minus 2BC cos A. Whereas sine rule will tell you that A over sine A is equals to B over sine B, which is also then equals to C over sine C. Now, when we are applying this method to an example, we use the same example as before, where we have a force of 13 Newton horizontally and a force of 15 Newton and the angle of 40 degrees to the horizontal. To use this method, we must first sketch the vectors from head to tail with their corresponding resultant. However, this time, we do not need the diagram to be to scale. So if we draw the vectors from head to tail, this is vector A at 13 Newton, followed by vector B at 15 Newton, and then this one was at an angle of 40 degrees. The resultant will be given by this gap, and it will be from the first point here to the last point here. We are interested in finding out the resultant R. Before we proceed any further, if you know that this is angle of 40 degrees, the corresponding angle here would be 180 minus 40, giving us 140 degrees. Now, let's try and use cosine rule to this triangle now. We make R the subject here, so R square equals to 30 square plus 50 square minus 230 times 50 cos 140. We will get the answer as 75.5 Newton. Now let's try and apply sine rule to find the direction of the resultant, which is given by angle theta here. Now, if we were to try and apply the sine rule here, we will try to take this pair and this pair, so that we get R over sine 140 equals to B over sine theta. If we sub in all the values, we will have 75.5 for R over sine 140 equals to 50 divided by sine theta. Eventually, we will get theta as 25.2 degrees. Notice that the magnitude of the resultant and the direction of the resultant is exactly the same as the previous method using resolution of vectors. Let's recap what we've learned. We've gone through three different methods to find a resultant vector. The first one being scale vector diagram, followed by resolution of vectors, and the last one being sine and cosine rule. Bear in mind that the first two methods is compulsory in your syllabus. You need to know that. Whereas the last method, sine and cosine rule, is actually optional. If you were to use it to answer your exam questions, do not worry, it is still acceptable. The marking schemes do allow it. Regardless of which method you use, the methods will only allow the magnitude and direction of resultant vector to be determined, but it won't tell you the point where it acts. What do I mean by that is that if you were to consider a circular object with forces F1 and F2 acting on it, if I were to ask you to determine the magnitude and direction of the resultant of these two forces, you will be able to tell me that if these vectors were drawn from head to tail, the magnitude and direction of the resultant will be indicated by this red line here. The question now is, where on this circular object would the resultant force be acting? To be able to determine the point where the resultant force acts, we first need to understand that vectors can be shifted along their line of action. What this means is that force F1 can be shifted along its line of action shown here, and force F2 can be shifted along its line of action shown here. The point where the lines intersect would actually be the point where the resultant vector acts. In this case, the point where the lines intersect is here. So the resultant will actually be acting here like this.